Hi ladies, Mr. O'Sullivan. Today we're looking at lesson 4-5, factoring polynomials using greatest common factor. Today's learning target is, I can factor a polynomial by using the GCF's leftover polynomial technique. Now here at BYW, we do GCF by using prime factorization. So prime factorization, you did this in elementary and middle school, and here's a little information about it. A prime number is a whole number greater than 1 that cannot be made by multiplying other whole numbers. Prime factorization is finding which prime numbers multiply together to make that original number. So for instance, if I look at the number 90, I can say 9 times 10 is 90. I could break apart 9 to be 3 and 3, but I can't break apart a 3 anymore because it would only be 1 and 3. I could break apart a 10 to be 2 and 5. So when I do the prime factorization of 90, I can say 90 is equal to 3 times 3 times 2 times 5. Now if you didn't know 9 times 10 was 90, what you could have done was just gone to our factor pair sheet and just zoomed in on the number 90 and used any of these combinations. So I could have used 2 and 45, 3 and 30, 5 and 18, 6 and 15, or 9 and 10. The nice thing is, each of those combinations, once you break them apart, will still give you 3 times 3 times 2 times 5, okay? So what we're gonna do is we're gonna do a little practice to use prime factorization to rewrite each of the following. So for the first example, we have the number 12. I can use 2 and 6 or 3 and 4. I'm going to use 2 and 6. Again, it does not matter. You can use 3 and 4. So 2 and 6. I can't break apart a 2 anymore, so I'm going to circle it. But I can break apart a 6. That would be 2 and 3. Now I wouldn't use 3 and 3 because 3 times 3 is 9. So now that I can't break apart those numbers anymore, I can say 12 is equal to 2 times 2 times 3. And that's your final answer. 2 times 2 is 4, times 3 is 12. Now, let's do the number 24. For the number 24, I can do 2 and 12, 3 and 8, or 4 and 6. I'm going to do 4 and 6. To break apart a 4, I would use 2 and 2. But the thing is, I can't break apart 2's anymore, so I circle them. And then to make a 6, I would do 2 and 3. And I can't break apart those anymore, so I circle them. So I could say 24 is equal to 2 times 2 times 2 times 3. And that's my final answer. Try to do the number 49 all by yourself. So if I do the number 49, I break it apart to be 7 and 7, and I can't break apart 7's anymore. So I would just write 49 to be equal to 7 times 7. And that's my final answer. Now for number 4, I have 25x squared. Do not worry about the x squared until the very end of the fact problem. So to break apart 25, I could do 5 and 5. And I can't break apart a 5 anymore, so I circle them. So I would say 25x squared is equal to 5 times 5. And now if I look, I have 2 x's because it's x squared. So I'd write this as x. That's how we would do the prime factorization of 25x squared. So the rest of this unit is going to be about factoring, and factoring is a verb. What it means to factor is to rewrite an algebraic expression using an equivalent product. So we're looking at how multiple things will multiply to make our original expression. The first kind of factoring you're always going to look for is GCF, which is the greatest common factor. You're going to take the prime factorization of each term, stack them on top of each other, and highlight what's in common. That's your GCF. So follow this procedure that Miss Daniel and I used to factor all these expressions. The first thing we're going to do is find the prime factorization of each of our terms. So if I look, my two terms are 6x squared and 10x. So I'm going to write 6x squared and 10x. Do not worry about your signs until the very end. I need to ask myself what makes 6, and it's 2 and 3. And I can't break that apart anymore. So I would say 6x squared is equal to 2 times 3, and then I would write 2 x's. But one thing that Miss Daniel and I would like you to do for all these examples here at BYW is to always write a times 1 at the very end. Now, to break apart a 10, I can't use 5 and 5, but I can use 2 and 5. And I can't break those apart anymore. So I can say 10x is equal to 2 times 5 times x. Now, those are stacked on top of each other. And what we're going to do is we're going to bring them down here. And we're going to highlight what's in common. So if I look, both rows have a 2, and both rows have a x. So I can say my GCF is 2x. So I would then write this as 2x, and now I'd write my leftover. So if I look at my first term, I have 3 times x, which is 3x, times 1, which is just 3x. So I have 3x, and then I have a plus, and then my leftover here is just a 5. Oh, I forgot to put a 1. Well, 5 times 1 is just 5. So my final answer would be 2x times 3x plus 5. And that's how I'd write this in factored form. Now let's look at our next example. We have 3x minus 24. So we want to figure out how we can break apart a 3x and a 24. So I can't break apart a 3 anymore, so it's already prime. So I can just write 3x to be equal to 3 times 1 times x. 24, though, I can break apart further. I can break that apart to be 4 and 6, 2 and 2, and then 2 and 3. And then we circle those primes. So I can say 24 is equal to 3 2s and a 3, and then a 1. So I'm going to just basically bring that down here. That way we can see it. And we're going to highlight what's in common. So both rows have a 3, and that's all they have in common. They also have a 1, but anything times 1 is itself. So I can say that my GCF is 3. So now I have 3 times, well, my leftover here is a 1 and an x. 1 times x is just 1x. I now have a minus. And then I do 2 times 2, which is 4, times 2 is 8, times 1 is 8. So I have a 1x minus 8. And that is how I'd write this in factored form. 3 times 1x minus 8. Number 3, 6x to the third minus 8x squared plus 2x. So we go ahead and do our prime factorization of each term. So we're going to do a prime factorization of 6x to the third, 8x squared, and 2x. So 6x to the third can be broken apart to be 2 and 3. We can't break those apart anymore. So I can say 6x to the third is 2 times 3, and then I'm going to do 3 x's, 1, 2, 3, and then a 1. 8x squared I can break apart to be 2 and 4, and then 2 and 2. We circle those primes, 2, 2, 2. So I can say 8x squared is equal to, let me change my color, 3, 2, so 1, 2, 3. And then I'm going to do 2 x's, 1, 2, and then a 1. Now, I can't break apart a 2x because it's already prime, 2 times 1. So I can just say 2x is equal to 2 times 1 times x, or 2 times x times 1. Now we highlight what's in common. And if we look at both rows, they all have 1s, they all have 2s, and they all have at least 1x. So I can say my GCF is 2x. So I have a 2x, and now I have to do my leftovers. So if I look at my leftovers, I have a 3xx, so 3x squared, minus 2 times 2 is 4, times x is 4x, times 1 is 4x. and then I have a plus. And if I look at my leftovers, it's just a 1. So this is my final answer, 2x times 3x squared minus 4x plus 1. And that's it for today. If you have any questions, email myself or Ms. Townsend.